Hi, in this video, we're going to talk about topic 0.4, trigonometric functions of the unit circle. So as always, you're going to write your last name and your first name on the page. And then we're going to write down the essential question in the I can statement. So how do you use the coordinates of the unit circle to find exact value? And I can use the unit circle to find the exact value of an angle based on the coordinates of the unit circle. So we're going to take what we learned yesterday and we're going to learn another way to do that. So again, remember between your essential question and your summary, you do need to have two comments or questions out here as part of our focus note-taking skills. All right, so again, you can always pause as you need to. I'm going to go ahead and get started and explain the unit circle. I am going to go ahead and close this little video so you can see the whole screen. So we are going to talk about a unit circle, and we kind of hinted at it yesterday that a unit circle is in fact a circle that has a radius length of 1 unit. So the equation of a unit circle is x squared plus y squared equals 1. And I know if you were in pre-calculus, maybe you saw this, but we didn't talk about the conic section equation of a circle. You may have seen this circle with radius length 1. You may have seen this in geometry. Sometimes they do it, sometimes they don't. It just depends on the year. So that is a unit circle. It's a circle with a radius length of 1. Each of the coordinates, each value on the unit circle corresponds to a set of coordinates which are listed as x comma y, or what coordinates are. But in our case for trig, the x corresponds to the cosine and the y corresponds to the sine. And it could be sine x, it could be, actually in this case, look, it says sine theta. So let's switch that to thetas. Cosine theta, sine theta. So you can see a couple of pictures. It doesn't matter though if the angle is positive, if it's going down, it's clockwise, it's negative. We still everywhere has a set of coordinates that we're going to work with. So in these first couple examples, we're going to determine the exact value of the 6 trig functions of the angle theta. So I'm going to start with example 1, and I'm going to start with sine of theta. So technically, we're just going to look at the coordinates. This is the angle. They told us that's the theta, so I'm going to use these coordinates right here. Remember, cosine is x, sine is y. So if I'm looking for sine, I'm just going to simply read the y coordinate. If I'm looking for cosine, I'm going to simply read the x coordinate. And then we talked yesterday about tangent, how tangent is the sine divided by the cosine. So that's exactly what I'm going to do. I'm going to put the sine over the cosine. Well, we're going to do a shortcut in a second, but I'm going to show you the long way first. So remember, when we have a complex fraction like that, we switch it to multiplication and we flip the reciprocal. And then we're able to cancel and we get 3 over -4 or -3/4. However, do you see what would happen? What really happened was these canceled. So the shortcut is you just cancel the denominators if they're the same, and it reduces to the exact same thing. All right, for the other 3 trig functions, we're just going to flip the reciprocals. So I'm going to flip the reciprocal of sine, which is cosecant, and that would just be 5/3. Secant is the reciprocal of cosine, and that would be just -5/4. And cotangent is the reciprocal of tangent, and that would be -4/3. And I want to take the simplified one and flip that reciprocal. So in example 2, we're going to do the same thing. Here is my coordinates. So I'm going to start with the sine. I just typically start there on the left. That happens to just be the beginning. Sine is the x coordinate, so it looks like it's -12 over 13. Cosine is sine is the y coordinate. I wrote it right, I said it wrong. Cosine is the x coordinate, it's -5 over 13. And then tangent, again, is we take our sine and we divide by our cosine. So a number of things happen here in this one. First of all, the double negative can be positive, and then we could take our shortcut. When that denominator is the same, we know in the complex fraction we can cancel it, so it's 12 over 5. Then we're going to go ahead and flip all of our reciprocals. So the reciprocal of sine is cosecant, and it's going to be negative 13 over 12. It doesn't matter where the negative sign goes. It can flip to back. It can just stay up at the top or be grouped out in front. The reciprocal of cosine is going to be negative 13 over 5. And the reciprocal of tangent is cotangent, and that's going to be 5 over 12.